Hello. The Australian Mathematics Competition AMC have just released their papers for 2023, and today we are solving the paper for middle primary. Let's go on. This is the first section. Question number 1 to 10 are all 3 marks each. They are multiple choice questions, and these questions are pretty easy and they should not take more than a few seconds for each question. Let's start. Question number 1. What is the total number of petals on all 5 flowers? Here are the 5 flowers. How many petals do you see? All right, so as you can see, on one flower there are 1, 2, 3, 4, 5 petals on each flower, and there are 1, 2, 3, 4, 5 flowers and with 5 petals each. So total number of petals is 5 times 5, which is 25. So 25 is our answer. There are total 25 petals. Let's go on to second question. There is a number statement here, 2 plus 3 plus 7 plus 8. What is the sum for it? You can do it in any which way you like, but the easiest way would be to group the similar, the number bonds to 10 first. So we can see 8 plus 2, that's 10. And then 7 and 3 makes another 10. So that's 10 plus 10 is 20. And this is the answer, B. Question number 3. Which of these shapes is a rectangle? Now, of course, we know that rectangle has 4 sides, and the angle between all 4 sides is 90 degrees. So this is our rectangle here. This is the rectangle number A. Question number 4. Which digital time matches the time shown on the clock face? Here is the clock face, and what time is shown? We can see this, the small hand is here, so it's past 9 o'clock. And how many minutes have passed since 9 o'clock? 5, 10, 15. So it's 9:15, and that answer C. This is our answer, 9:15. All right, again. Emma has a bag containing 5 red, 4 yellow, 1 black, and 2 blue buttons. When she chooses one button at random, what color is it most likely to be? Now she's choosing at random, so the most likely would be thinking about how many buttons are of each color. Now since we see that there are 5 red buttons, which are more than any other, so the chances for red to be chosen is much higher than any other color. So the answer is red. Question number 6. What fraction of the circle, there's a circle here, what fraction of the circle is part A? Now there's part B given, but that's just to confuse you. We're only looking at part A. What is part A of the whole circle? We already know this is 1/4 or 1/4. So here is our answer, D. There's a circle that's divided into 4 parts, and this part is 1/4. B is just there to confuse the students. All right, the question number 7. In a board game, Nick rolls 3 standard dice. We can see that's 3 dice here, one at a time. He needs his 3 rolls to add up to 12. So they all need to add up to 12. His first 2 dice rolls 5. We can see here 5, and there's 3 here. What does he need his third roll to be? So he has 5 already. On the second dice, he has 3. How much more does he need on the final dice, on the third dice, to make a total of 12? So this is 8. This is simple. 8 plus something equals 12, and that answer has to be 4. So he needs a 4 on the last dice to add up to 12. The answer is C. Question number 8. Which shape has only one line of symmetry? Now, they all can have lines of symmetry, but we are looking for a shape which has only one line of symmetry. That is important to read the question. Only one line of symmetry. Now, this let me draw those lines of symmetry. This has this line of symmetry, and this can also have this, also have this. So this has multiple. Square, we know it has 4 lines of symmetry. Similarly, this seems like a regular pentagon. It will have multiple lines of symmetry, much more than one line of symmetry. So this cannot be. Similarly, this is a regular hexagon, and this will have many lines of symmetry. Only the trapezium here will have one line of symmetry, which is right here. Let me draw it again. I'm sorry. This is the line of symmetry. So our trapezium is the answer. So E is our answer. That's the only line of symmetry we have for answer E. Question number 9. Anesthesia ant is on the sheet of wire mesh with 10 centimeter squares. Here is our ant that we are talking about, and this is a grid of 10 centimeter squares. That means each square here and here is 10 centimeters length and 10 centimeters wide. She can only move along the wire. She moves 10 centimeter east. Now let's track the path. So from here she goes 10 centimeters east. So she goes here, and then 30 centimeters north. North is here, so she has to go up first from here. 10, 20, 30, and then 20 centimeters west. West is on the left side, so 20 is here. So she ends up here. Let me mark it. So she starts from here and ends here. The question that they're asking is, what is the least possible distance she needs to move to return to her starting point? If she has to come back to the beginning using the least possible distance, we can see that she can go here, and this would be the smallest path, the shortest path, because she can only travel on the wires. And this is 10, 20, 30, and then 40. So this is 40 centimeters. That's our answer. Next question. Now this was a very interesting question, which requires a bit of visualization as well. So let's read the question. A piece of card is cut out and labeled as shown in the diagram. This is our cardboard cut out, and it is marked A, B, C, D, E faces. It is folded along the dotted lines to make a box without a top, and we can see this will be the final box that we are trying to make. Which letter is at the bottom of the box? We are looking at the bottom of the box, so let's try to see that. Now, in order to find the bottom, let's look at it carefully. Now, if we were to fold this mesh, this line here we join with this line here, and let's change my color. This line here will join up with this line here if we fold this up. All right, so this will be joined together if you can visualize it, and then this line here will actually come with this line here, and this line here we come up with this line. So if you can visualize it, the bottom is this part. B would be at the bottom. So it would be, let me write it down. So it will be D here, D's here, and on one side is C, on the other side or the back side will be E, and this A will come join these two sides here, so the A will come behind. Only this is the part B which will come at the bottom of it. So our answer is B. video we'll be solving questions number 11 to 20, which are 4 marks each. These questions are slightly difficult than the first section, but still easier than the next two sections. All right, let's go on. Question number 11. Xiang is threading beads onto a string to make a necklace. We can see here. All right. He decides to use a sequence starting with a red bead, then a yellow, and then a blue bead. And we can see the pattern here. He uses red, then a yellow, and then blue. And this is the pattern that he follows on to make the whole sequence. He repeats this pattern until he has 20 beads on the necklace. So he uses 20 total beads. How many red beads will he use? So we have to count only the number of red beads. Now, as we can see in a pattern of 3, he has 1 red, 1 yellow, and 1 blue. To use up 20 beads, he will, of course, each pattern requires 3 beads. He will have 6, 3 times 6 is 18, and this will use 18 beads. So if we repeat the pattern 6 times, he would have used 18 beads. And then 2 more beads. And of course, he has to start with this. So it will be a red, if I can get a red. So after the 6 patterns, after the 6 cycles of this pattern, there is 1 red. And there is 1 yellow. And there are 6 iterations of the same pattern. Now we can see, let me grab red because we are trying to find red beads. So in these 6 patterns, 6 iterations of this pattern here, he must have used 6 red beads already. And with the 2 beads here, we can see that we have used 1 red bead. So 1 more bead, so that's total of 7 beads, 7 red beads. So let's see our answer. We have used 7 red beads in a pattern, while he has used 20 beads on the necklace. So the answer is 7. All right, question number 12. How many people played tennis on the busiest day of the week? We can see the graph here, the picture graph. And the busiest day, as you can see, is Thursday. This is Thursday, which maximum people are playing on. And how many people play tennis? So let's see, each ball represents 10 players. So that's 10, 20, 30, 40, 50. And there's half a ball here, which represents half of 10. That means 5. So this is 55 players. So our answer is 55, which is C. This is our answer. Question number 13. When the puzzle is complete, each of the 4 lines will add up to 14. So let's see, this will add up to 14, and this will add up to 14, and this will add up to 14, and this will add up to 14. So all of these will add up to 14. What will the 4 missing numbers be? Add to? So to find out what they will add to, first we need to work out what these different numbers are. So let's zoom in. So we know this is 6, this is 5. So in order for this line to make 14, 6 plus 5 is 11. And to make 14, we need 3 more here. So that this line is 14 here. And now similarly, if we look at this row here, there's already a 2, already a 5, that's 7. And to make it 14, we need a 7 here. So we know this one. Now let's look at this column here. We already have a 7, we have a 3, that's 10. To make a total of 14, we need a 4 here. And now finally, let's look at this row. We have a 4 and a 6, that's 10. So we need another 4 here to make a total of 14. So we have now the 4 missing numbers, and now we can add the missing numbers and add them together. So we have 3, 7, 4, and 4. These were the 4 missing numbers, and we can add, this is 10 and this is 8. So that's 18. So the 4 missing numbers add up to 18. 18 is our answer. Let's go to question number 14. Now this is a very interesting one. This is one of my favorite questions on this paper. Which one of the following could give an answer of 25? So we are looking to give the answer of 25. Now note, 25 is an odd number, all right? This is an odd number. Which of these calculations can actually yield an odd number? Let's see the first option. An odd number plus an odd number. Now, if we add any two odd numbers, the answer is always an even number. Odd plus odd always gives an even number as the answer. So this cannot be our answer. You can try with different examples. Now, let's try the second one. An even number multiplied by an even number. Now, because it's an even number, all the multiples of an even number are also even. So you can try an even number. Let's take 4, multiply it by another even number. You can try anything, and the answer will always be even. So it cannot yield a an odd number. So this does not work. The next one, let me highlight it. An even number divided by an odd number. Now let's try to work this out. An even number, let's try to take 20 divided by an odd number. Let's try to divide it by an odd number, which is a factor of it. 20 divided by, it will be 4. It will always, you can try different answers. Answers will always be even. It cannot yield a odd number. So our C option is not correct too. Let's go to the next option, an odd number minus an even number. Let's try to work that out. An odd number, let's take 15, take away an even number, let's take 4 out, and answer is 11. And this is one of those options which can give us an odd number as an answer, all right? And let's look at the last calculation too. An even number multiplied by an odd number. Even number 4 multiplied by an odd number 3. Again, the answer is an even number. So this option is also not correct. So only option correct is D. D is our answer. And actually, if you think about it, you can even work it out to get a 25. You can start with an odd number minus an even number. So you can start with 27, take away an even number 2. And that will give you 25. And you can have multiple answers. You can have 31 and you can take away 6 and that will give you 25. So you can get this answer of 25 using multiple strategies, using the same formula. An odd number, take away an even number. The answer is D. All right. Next question. This bottle holds 4 glasses of water. So this bottle here can hold 4 glasses of water. Which one of the following holds the most water? Let's look at example number A. So there are 4 glasses here, 4 glasses here, 4 glasses here. So this can hold 12 glasses. Now this here is directly glasses 1, 2, 3, 4, 5, 6, 7, 8. This is 8 glasses. And here, there's 4 glasses of capacity in this, 4, 5, 6, 7. So it can hold 7. This is a capacity of 7 glasses. Similarly here, 4 here, and 1, 2, 3, 4, 5, 6. So 4 plus 6 is 10. So this is 10 glasses. And here is 4 glasses capacity here, 4 here, and 1 here. 4 plus 4 plus 1 is 9 glasses. As we can see, the maximum, which of these following options holds the most water, is 12 glasses. That is A. A is our answer. Let's go on to the next question. All right, let's read this question. Fido needs to be weighed at the vet, but he won't sit still. So the vet weighs himself. So this is the weight of the doctor himself, the vet, and then he weighs himself holding Fido. So this is weight of wet plus Fido, and this is only the weight of the wet. So how much does Fido weigh? Of course, so let's read this. The weight of the wet is, this is 70, and because we have 5 markings between 70 to 80, so each of these little markings account to 2 kilograms. So 70, 72, 74, 76, 78. Let me show you clearly. All right. So as you can see, this point refers to 78 kilograms. Now let's say look at wet plus Fido. Again, let's say this is 100, and then because each little marking is 2 kilograms, so this is 102 kilograms. So if you have to find the weight of Fido, we have to take the weight of wet plus Fido and then deduct the weight of wet. So this is 102 minus 78, and the answer is 26 kgs. And let's see the answer. This is B. Let's look at the next question. Grandma adds 3 spoons of sugar to the juice of 10 lemons to make lemonade. So for every 10 lemons, she has to add 3 spoons of sugar. How many lemons are needed to if 15 spoons of sugar are used? So let me work it out. So this is sugar is to lemons. So if she uses 3 spoons of sugar, she has to use 10 lemons. Now it's already given that she has used 15 spoons of sugar. That means 5 times of the original. And to keep the ratio the same, we have to use 5 times of lemons too. And that means we have to use 50. So 50 lemons, let's see, our answer is E. So for 15 spoons of sugar, she must add 50 lemons to make the lemonade. Oh, this is again a very, very interesting one. And there are multiple ways to find out the answer. Let's try to read it and work it out. So Janice is making patterns using square tiles, as we can see here. All right, each pattern is made up by copying the previous pattern, then adding new tiles around the edges. As we can see, they started from here, then moved on here, added more tiles and more tiles. The new tiles alternate in colors as shown. Here we can see we started with black, then they added the light color, the purple colored, and then they added the black tiles again on the edges, and then the purple tiles back. Now let me remove all this. Oh, sorry. All right, the question is, so this is pattern 1, pattern 2, 3, 4. What will be the total number of tiles in pattern 5? So the pattern 5 is the next pattern. We have to determine how many tiles will be used. Now there are multiple ways to do it. The easiest way, I'm so sorry. The easiest way is to actually color in and because the next tiles will be black, so let's try to color in all the tiles that will be added. So 1, so these are all the tiles that will be added in the next pattern. All right, and you can just go on to count these tiles, starting from 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and you can count on and you will get the answer 41. There are 41 tiles. But of course, if you don't want to use this method, let's try to form a pattern of sequence as well. Let's start from the beginning. So let's have a look. In the first pattern, we used one tile. All right, in the second one, there's one tile and then 4 tiles more are added. 1, 2, 3, 4. In the next pattern, there's one, of course, that we started with. Then there are 4 around. And how many new tiles are added? 1, 2, 3, 4, 5, 6. 4, oh no, sorry. Let me change the color so that it's easy. So there's one here already. We have one here. And then 1, 2, 3, 4. Those were added in the next pattern. And now let's see how many tiles are added in pattern number 3. 1, 2, 3, 4, 5, 6, 7, 8. So there are 8 more added in this pattern. And let's continue. In the next one, of course, we have 1 and 4 and 8 for sure. Let's see how many new are added. So we have 1, 2, 3. Let me change the color to make you see better. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So there are 12 more added. Now you can already see how are we proceeding on, and we can already see in pattern 5 how many tiles will be used. So we will have all these previous ones for sure. 1 plus 4 plus 8 plus 12. And following the pattern 4, 8, 12, we can see in the next one, we will be adding 16 more tiles. And now you can go on and add these. 12 and 8 is 20. 16 and 4 is 20 again. And there's a 1 here. So that's 41. So we have used 2 different methods to find the same answer. The answer is 41. And there are multiple other ways that you can do to find the answer, but you will always get 41. All right, let's read the next question. All right, my laptop's battery meter tells me what fraction of the battery charge is left, just like our laptop or phone. I used the laptop for 4 hours and 20 minutes, and it went from, let's read it. So it was 100%, and we can see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 bars that represents 100%. So each of these little bars represent 10%. All right, and it went from 100% to 1, 2, 3, 4, 5, 6. Only 60% battery is remaining and 40% is drained. So 40% battery is drained in 4 hours and 20 minutes. Now you can calculate that if I have to, so if 40% gets used up in 4 hours, 20 minutes, so 10% of battery, that means each of these little bars, 10% battery will be used. You can divide that whole thing by 4, and this will be 1 hour, 5 minutes. And this information is important. So 10% of battery is used up in 1 hour, 5 minutes. Now let's read the question, rest of the question. What would be the reading be after using the laptop for another 130 minutes? Now 130 minutes is 1 hour and, sorry, not 1 hour, 2 hours and 10 minutes. 2 hours and 10 minutes, and we can see from here this would require 20% battery. So if we use the laptop for 2 hours, 2 hours and 10 minutes, it will drain 20% more battery. So it was already at 60% and it drains up 20% more battery. So that means it will be, these two will be gone, and we will be left with 40%. Now let's see where is showing 40%. Not here, not here, not here. Our answer B is the correct answer. B is our answer, which shows 40%. 40% battery is remaining. Let's go on to the last question of this section. Said's mother has some money to share with her family. Now, this is again one question. I've had a look at this before. This can be used by a pictorial method or by using a reverse method. Let's I will show you both the methods. She gave 1/4 of her money to Said. Then she gives 1/3 of what is left to Ahmed, and then she gives 1/2 of what was left to Ryan. She was left at the end with $15, which she kept for herself. How much money did Said's mother have to start with? Now, let's to understand this really nicely. Let me remove all this first. All right, draw. I'm looking for the shapes. Not able to find the shapes for some reason. All right, I will just draw by hand. So if this represents the total money that Said's mother had at the beginning, and it says that she gives 1/4 to Said. So 1/4 means 1/4. So let's divide this into 4 equal parts, and she gives one of these portions to Said. All right, so now that means she has this part left over. Then she gives 1/3 of what she has left to Ahmed. Now, because she has this much part left, and this is easy calculation actually, because this is already divided into 3 equal portions. So she gives 1/3, which is 1 part out of the 3 equal parts, to Ahmed. Now, after giving to Ahmed, she has only this much left, and then she gives 1/2 of what is left to Ryan. Now, this is becoming actually an easy question, because we can see her leftover portion is already divided into 2 portions, and she is giving half. So that means 1 part of the 2 equal parts to Ryan. And then she was left with $15. So she's left with this money, and this is 15. Now we can see, like, right from the start, we did not have to portion out the whole thing again and again. This was right from the start. We divided into 4 equal parts, and we did not have to partition it further. So if this is 15, that means this is 15, 15, and 15. So the total amount right from the beginning should have been 15 times 4. 15 times 4, it's $60. So she started with $60. So how much money did she start with? She started with $60. All right, now I promised you I will show you another method to do this question. Let me remove this. Now, the other strategy this was easy because we did not have to partition it further, but in some questions we have to use different diagrams, and that sometimes can get really complicated in a pictorial way. So let's try this other way. In this way, we have to start from the end and go backwards. So she has $15 left with her, and then go back to the previous one. She gave half of what was left to Ryan. So that means she must have given 15 to Ryan too. So that means before this step, she had $30. Now let's go to the step before this. She gave 1/3 of what was left to Ahmed. So she had given 1/3 to Ahmed, and this was the 2/3. So this was the 2/3, and 1/3 has gone to Ahmed. So we can see if this is 2/3, 2 portions out of the 3 equal portions. So if we calculate that, that's 2 equal portions. That means 15 and 15, and that must be 15 as well. So that means before this step, she had $45. Now let's go to the previous step. She gave 1/4 of her money to Syed. So if before that, she gave 1/4 to Syed, and she kept 3/4 for herself, so which was $45. So we can see if this is 3/4, that means each equal portion has to be 15. So 1/4 side also got $15. So that means at the beginning she had 45 left, 15 to side, she has $60. All right, so she began with $60. We got the same answer in a different way. This question worked better in a pictorial way. I hope all the answers are clear. I mean, if you haven't checked them out yet. In this video, we are going to solve questions number 21 to 25, which are 5 marks each. And this section 3 is comparatively much more challenging than section 1 and 2, and probably will take a few minutes for each question. All right, let's start. Question number 21. In 2023, Janine's birthday is on a Thursday. Knox's birthday is 1 month later, exactly 1 month later, meaning that it is on the same day number. That means if Janine's birthday fell on a second, Knox's birthday will fall on a second too. So the date will be the same number in the next month, exactly 1 month later. Knox's birthday is not on a Saturday or a Sunday. Which day of the week is Knox's birthday? Now, we don't know which date is Janine's birthday, but we do know, let me write it down. We do know Janine's birthday is on a Thursday. Now, because Knox's birthday is exactly 1 month later and the year is 2023. Now, 2023 is not a leap year. So each month can have either 28 days, 30 days, or 31 days. These are the 3 options. And because the birthdays are exactly 1 month apart, the same date, that means between Janine's birthday and Knox's birthday, there can be exactly 28 days or 30 days or 31 days, depending on which month are they talking about, but we don't know. Let's see the options. So we always start with the Thursday because we know Janine's birthday is on a Thursday. Now, if it was 28 days, 28 divided by 7 days of a week is exactly 4. That means if it was a 28 days month, that means if Janine's birthday was in February and Knox's birthday was in March, exactly 28 days later, Knox's birthday will fall on a Thursday too. If it was any other month with 30 days in between, so 30 divided by 7 will be 4 weeks plus 2 days. That means it will be Thursday, 4 weeks already, and 2 days, Thursday, Friday, Saturday. It will fall on a Saturday. And similarly, if it was any month that has 31 days in between, so that means 4 weeks plus 3 days, and that means Knox's birthday will fall on a Sunday. Now, in our question, they have already mentioned that Knox's birthday is not on a Saturday and Sunday. So Saturday and Sunday are not possible. So the only option left is a Thursday. So the answer is Thursday. This is our answer for this. Question number 22. Sally empties her piggy bank to see how much she has saved. She has 20 coins altogether, and the total value of her coins is $3.80. $3.80. She notices that she has twice as many 50-cent coins as compared to 20-cent coins. The remaining are 10-cent coins. How many 10-cent coins does she have? Now, in order to work this out, I made a table to help us, and we know that she has only 3 types of coins. She has 50-cent coins, 20-cent coins, and 10-cent coins. We do not know how many, but we do know that the total of all her coins is $3.80, and she must have 20 coins in total. Now let's see the different scenarios in this in which this is possible. Now we know that whatever amount she has in 20-cent coins, she has double coins into 50 cents. So let's start with the basic one, start with the easiest one. If she has one 20-cent coin, that means she must have 52-cent coins. Now, no, two 50-cent coins, sorry. So that means in amount wise, this is $1 and this is 0.20. That will amount to 1.20. That means in order to make it 3.80, we still need 2.60 more. That means we need 26 coins of 10 cents, which will amount to 2.60, and the total will become 380. But in this case, as we can see, 2, 3, and 26, those are 29 coins. And that cannot be an answer because we just have 20 coins. So this is not our answer. Let's try another possibility. If she has two 20-cent coins, that means she must have four 50-cent coins. Let's think about the value. So if she has 4 coins, that amounts to $2, and 2 of 20 cents, that amounts to 40 cents. So that is 240. So that means we need to have 140 more in order to make a total of 380. So that means she needs 14 more coins. Let me change the color. She needs 14 more coins to have a total of $1.40, and the total will come out to be 380. Let's count the number of coins. So 4 and 2, 6, and 6 and 14 is 20, and those are the number of coins that we were looking for, 20. So actually we do not have to look any further. We found our answer. But any case, if this could not work, we could have gone ahead to try 3, 6 and work out different coins, or 4 and 8 and so on. But here we don't have to go any further because we found our answer, because this amounts to 20 coins, which adds up to $3.80, and it applies all the conditions given in the question. So our question was, how many 10-cent coins does she have? So she has 14 coins. Our answer is E. Question number 23. 3 different numbers are chosen from 1 to 20. They add up to a total of 20. 2 of those numbers are 2 apart. How many possibilities are there for the largest number? Now, I did make a table here to help us determine these 3 numbers. So as we are choosing 3 different numbers, and they have to be from 1 to 20, and 2 of those numbers are 2 apart. That means whatever number is here, let's call this number A. So whatever number is here, let's say 2 apart, so the other one has to be 2 more. All right, we could have used 2 less as well, but like I'm using 2 more, so they are 2 apart. I can see these 2 numbers are 2 apart. All right, and the next number can be anything, but the total has to be 20. All right, now let's see the different possibilities. Now, because it's a number from 1 to 20, let's choose the smallest number which is possible for 1. So if the first number is 1, the other number, one of those other numbers has to be 3, 2 apart. So 1 plus 3 is 4. That means to make a total of 20, we need a 16 here. This is one of the possibilities. Now let's go to the next one. If this is 2, the other one has to be 4. That's 6. That means the other number, the third number, has to be 14 to make a total of 20. Similarly, if this was 3, this has to be 5. That's 8. That means the other number, the third number, has to be 12. If this is 4, this has to be 6. That's 10. That means the other number, the last number, has to be 10. If this was 5, this has to be 7, one of those numbers. 5 plus 7 is 12. That means we need 8 more. All right, it's going on well. If this was 6, that means one of the other numbers has to be 8, 2 more, and 6 plus 8 is 14. That means one more should be 6. But actually, this case scenario, will not work because we are using two different 6 and we do not have two coins of the same number. They are all different numbers. So this scenario will not work. So let me rub that out. So 6 did not work for us. Let's go to 7. If the smaller number was 7, that means this number has to be 9. 9 by 7 is 16. That means the other number has to be 4. All right. If this was 8, this has to be 10, 18, and then other number becomes 2. All right. Now, if we carry on, let's say if this number was 9, this has to be 11. And that's already 20. 11 plus 9 is 20. And we do not have a 0 as the third number. So actually, any number bigger than 9 will not work for us because that will already add up to more than 20. See, so these are only the scenarios which are possible. Now let's see, they are asking us how many possibilities are there for the largest number. Now let's see, in the first scenario, the largest number is 16. In the next one, 14. Next scenario, 12. The largest number in the next scenario is 10. In the next scenario is 8. In the next scenario is 9. And the next one is 10. But we already have a 10 here. So this is a repeated one. So we should not count this. So let's see how many different possibilities are there. 1, 2, 3, 4, 5, and 6 different possibilities. Oh, tease. So our answer is A. Question number 24. Estelle is making decorations shaped like an 8-pointed star shown below. So this is the star she's trying to make. She folds a square paper. She starts from here. She folds a square paper to make a triangle with 8 layers as shown. So we can see that she takes a paper, folds it along these lines. That becomes half, and then folds along this line, and then folds along this line to get this shape. And then she makes the cut. So it has symmetry. All right, so the question is, how could she cut the triangle so that the unfolded shape is the star? So from here, in this shape, which of these cuts should she make to finally get an output like this? Now, for the people who have good visualization, they can think about it and get the answer straight away. For people like me who do not have good visualization, this is a method that I use, and I'm going to show you, and you can use that. All right, now, because we know it was folded here and then here, we'll talk about the triangle later. So that means it should have 4-fold symmetry. So let's have a closer look at the star. And let's try to say that the first fold was here. The second fold was here. It's not straight. Let me try to write again. All right, not very clear, but let's focus on this part here. So just to keep it in the same orientation as in the question. Now, as we can see, the last part, it was folded into a triangle. So according to lines of symmetry, the last fold should have been here. And let's finish the triangle. So this was a square I had, and she folded it along. So let's look at this triangle. Let's see, we can already see that the cuts she has made, just focusing on this, is here and here. And now we can easily see that, and that this is when opened up will give all the 8 pointers. Now we can see from the options here, A, B, C, D, E, this cut looks similar to the cut in B. So B is the right option. Now you can grab a piece of paper and actually try to work it out by yourself. You will get the same answer. Question number 25. Tom is digging holes in his garden for his new plants. As he's working, he slows down. Each new hole takes a minute longer to dig than the last hole. So each new hole that he's digging is taking more time. So if the previous hole took 2 minutes to dig, the next one will take 3 minutes, and the next one will take 4 minutes, and so on. Now, first 5 holes have taken him 35 minutes in total. How long will it take for him to dig the next 2 holes? All right, now, as we know that he is not working at the same speed, his time is increasing with each next hole that he's digging. But let's say that in total it's 35 minutes for 5 holes. So if he was working at the same speed, if he took the same amount of time for each hole, so 5 holes took him 35 minutes. Now, just to make our working easier, if we assume that he took the same amount of time for each hole, so that means one hole would take 35 divided by 5, which is 7 minutes. So this is our average. So let me write now. So 1. So first, second, third, fourth, and fifth. So if these were the times taken for the 5 holes, our average is 7. So that will come 7 here. If everything took 7 minutes, these would be our timings, but that is not the case. So the 7 would remain here for here and here. The one before would take 6 minutes and the one after would take 8 minutes. Similarly, the one before would take 5 and the one after would take 9. And this still works. You can check because the average still is the same. So 7 plus 7 was 14 and 9 plus 5 is still 14. 7 plus 7 is 14 and 6 plus 8 is 14 and 7 remains the 7. So yes, the total will be 35 minutes for this one if it was digging at the same speed, and the total is 35 minutes here as well. So we know he started, the first hole he dug took 5 minutes, then 6 minutes, then 7, then 8 and 9 minutes. Now the question is, how long will it take for him to dig the next 2 holes? Because he's at 9 minutes already, so the next one will take 10 minutes. And so the next 2 holes will take 10 and 11 minutes, and the sum of it is, so if you add 10 and 11, that will give you 21 minutes, and that is our answer. So the next 2 holes will take 21 minutes. So of course in the answer sheet, yes, so C, that is our answer for question number 25. All right, now I'm adding the link here to the next section of videos, which is section number 4, which is the last section, and these are the most challenging questions of the paper. So these will take a little bit longer. So the link is up here, you can watch that video. Hello everybody, so here we are on the last section of AMC, Australian Mathematics Competition for 2023. All right, so these are questions 26 to 30, and these are some of the most challenging questions in the paper, and they go in increasing order of difficulty. So question number 26 is for 6 marks, 27 is for 7 marks, 28 is for 8 marks, 29 is for 9, and the final question, 30th, which is supposed to be the most difficult question of the paper, is 10 marks respectively. All right, and do expect them to be like really difficult questions, and be prepared for a detailed working out to find the answer. All right, let's go. Question number 26. To unlock a security code, Danielle enters a code on the keypad shown. Here is our keypad. Now these are some clues to find out the code. To make it easy to remember, the code has 10 digits. The code uses every digit exactly once. So we can see there are digits from there are numbers from 0 to 9. These are the digits on the keypad, and every digit gets used once. There are 10 digits and all of them get used exactly once. The next clue, the code steps from button to button only if 2 buttons touch. Now this is an important clue. What it means is if you are on a 6, so from 6 you can only go to the button that touches it. So that means 3, 7, 0, 9, 5, 2. So you have the possibility to go to any one of these buttons if you haven't visited them before, but you cannot go to 1, 4 or 8 because that's not touching the number 6 button. All right, so make sure when you try on different codes, you can only go on the buttons which are right next to them, and you cannot revisit a number because we can only use the digits exactly once. So these are some clues that you have to take care, and you might have to possibly try a few numbers before you can find the right answer. And the code is as large as possible. Now there, of course, we can make different codes using the earlier clues, but this clue is very important. The code is as large as possible. Now, remember to use all the clues and find out our answer. So I've zoomed into it so that we can look at it carefully, because we know there are 10 digits. So let me make space for 10 digits. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So these are the spaces for the 10 digits. Let's start, because we are looking for making it the highest number, the largest number. So of course we have to start with 9. That's without a doubt. And from 9 we have an option to go to 0, 6, 5, 4 or 8. But because we have to make it the largest number, of course we will choose to go to 8 from here. So 9, 8. Now from 8 we have option of going to 4 or 5. There are just 2 options. Now again, because we are trying to make it a big number, we will choose to go to 5. Now 5, now this is the tricky position, because we have 4 options: 4, 1, 2, 6. Now some people might think 4 is easier because from here you can cover all the way, but do you see, because the moment you put a 4 in this place compared to the number, if a 6 comes in this place, so imagine a 4 or a 6, you have 2 options. So of course we will go with a 6 here to make our number large. So from here it goes to 6, and from here, remember, we have to cover all the numbers. So from here, although we do want to go to 7, but if we go to 7, the problem is we can either go this way or that way, and we will not be able to cover all the digits. So at this moment, although we do want to go to 7, that would be a large number, but actually we will need to go to 0 in order to cover all those remaining digits as well. So 0, and then the moment you have made this decision, everything else falls in place. Now 7, then 3, then 2, sorry, why did I write 3? 2, 1, and 4. So this is our code. Of course, if you are trying out and you have written a different code, remember, these are very tricky questions. Do not just try one number and move on to the next question. Do keep thinking about it, because it sometimes takes a while to finally get the right answer. So in the question, they asked us, what are the last 3 digits in Daniel's code? And those 3 digits are 214. So the answer is 214. This is our answer for question number 20. Question number 27. In this puzzle, the triangle, the square, and the circle represents different non-zero digits. None of them are 0. Here we can see these are the 3 shapes that are used to denote 3 different digits and non-zero digits. What is the 3-digit number represented by the triangle, square, and the circle? Now let's look at this equation closer. Let's have a closer look. All right, we are multiplying by 3. Now if we actually look at the times table of 3, how many options are there? Now what we can notice is whatever digit will appear here in the answer, the units place must be the same digit, because it's the same circle on both places. So if I actually, let's take an example. If I have a 1 here, but 3 times 1 is 3, but this and this represents circles, they should have been the same. So we cannot have 1 here. Similarly, let's try different. Can I have 2 here? 3 times 2 is 6, so 2 will not work. 3 times 3 is 9. That cannot work. Those have to be the same digits. 3 times 4 becomes 12, so it will be 2 here, which is not the same as 4. This will not work. 5, 3 times 5 is 15. Now have a look. So actually the digit here will be the same as Eunice's digit here. So we have found our first the circle must represent 5, and we can actually keep looking at different options. 6, 7, 8, 9. We cannot have 0. You can try different options here. There is no other digit which complies with this condition, that if you multiply it by 3, the units place of the answer will be the same digit. So this has to be 5. We worked out one of those, and this will be 5 as well. Now 3 times 5 is 15, so that has a 1 exchange. Now again, what number should appear here? So 3 times something and add a 1 should end up with a 5 in the units place. If we have a 1 here, 3 times 1 plus 1 is 2, so 1 will not work. Can I have 2 there? 3 times 2 is 6 plus 1 is 7. That's not a 5. That will not work. 3 times 3 is 9 plus 1 is 10. That will be a 0. That does not work. 4, 3 times 4 is 12 plus 1 is 13. That does not work. 5, 3 times 5 is 15 plus 1 is 16. That does not work. 3 times 6 is 18 plus 1 is 19. That does not give a 5, so 6 does not work. 7, 3 times 7 is 21 plus 1, 22. That does not work. 3 times 8 is 24. Add a 1, and that becomes 25 with a 5 in the units place. And we found our answer. So there was an exchange of 1 here, and we just found out that 8 should be the digit here. So 3 times 8 is 24 plus 1 is 25. 5 goes here and 2 goes exchange on the hundreds column. Now it's again, we found our square is 8, so the answer here has to be 8. Now it's easy peasy. What digit should appear here? So that 3 times something plus 2 is 8. Of course, that does not require a lot of calculation. It should be 2. 3 times 2 is 6 plus 2 is 8, and that gives our answer. So the question asked, what is the 3-digit number? Triangles, square, and circle. That is 2, 8, 5. That's the answer. On to question number 28. Ollie arranges number 1 to 6 to form 3 two-digit numbers. So we have space for the 3 two-digit numbers here. Exactly one of his numbers is divisible by 3. All right, exactly one number is divisible by 4, and none of them is divisible by 5. Another clue, the 3 numbers add up to 93. Now what is a number which does not divide by either 3 or 4? So we'll find out the answer later on. Let's work out the different options possible. So let me just write down what digits are available. So we have 1, 2, 3, 4, 5, and 6. So these are the options, and each digit may be chosen just one. Now, one striking clue is that none of the number is divisible by 5. That means this 5 cannot appear in the ones place in any of those numbers. So let's just write the possibilities. So I'm just writing the possibilities for the tens column here, and the possibilities for the ones column in this blue. So we can see, because 5 cannot appear in the ones column, so 5 has to be in the tens column. So 5, I do not know which number, but 5 has to be in the tens column. Now another one is, because the 3 numbers have to add, these numbers have to add to 93. So one of the digits is 5 already. So I can say, if I choose, we cannot have 6 over here. 6 is the option in the tens column, because the moment I put 6, 6 plus 5 is already more than 100. It will go in the hundreds column. So 6 actually has to be an option for the ones place. All right. Now, because I have again a 5 already, I cannot even have a 4 in the tens column, because 5 and 4 and any of the other digits, if I choose, that will lead me to go to hundreds column, and that is not possible. So 4 has to go in the ones column as well. All right, so 4 is done. Now, if 4 is done, what else do we have? Because we have to make 93 here, and I already see there's a 6 and a 4, that is 10. That means from this column, there would be an exchange to the tens column. Now this, of course, is a lot more thinking, a lot more processing. This is question number 28, and it is worth 8 marks. So there has to be a lot of processing going on in your brain to find out the answer. It's not easy, of course. So because there'll be an exchange of 1 here, there will be an exchange of 1 here. That means we have to finally get a total of 8, and plus 1 will make it 93. These have to add up to 93. So we already have a 5, and we need 3 more. There is only one possibility to get 3 more, is 2 and 1. So the options for the tens column are 5, 1, and 2, and of course the 4 will have to, the 3 will have to go in this column now. All right, so we have got, at least we sorted out which 3 digits can go in the ones column, which 3 digits can go in the hundreds column. Now let's look at the other clues. So only one number has to be divisible by 3, and only one number has to be divisible by 4. So if you have to try different combinations and see what works for it. If we just go with these combinations written here, 23, 56 and 14, I can see actually 3, 6 and 5 is 11, 5. None of these numbers is divisible by 3. So we would need one number to be divisible by 3, and none of these numbers work. So we have to think of a different combination. So this is trial and error. You have to try a different method. So let's try 54, 23, and 16. Let's have a go. So we can see 5 plus 4 is 9. So this number is divisible by 3. And let's check if other numbers are divisible by 3. This is not. This is not. So exactly one number is divisible by 3. Now, according to the clue, exactly one number should be divisible by 4. And we can see 16 is divisible by 4. And 23 is not divisible by 4. 54 is not divisible by 4. So actually, this arrangement fulfills all our conditions. This arrangement fulfills all our conditions. 54, 23, and 16, they add up to give 93. Exactly no number is divisible by 5. One number is divisible by 3. Exactly one number is divisible by 4. So we have found our 3 numbers. Now, the question is, what is the number which does not divide by either 3 or 4? So this is the number which divides by 3, this is the number which divides by 4, and the number that does not divide by 3 or 4 is 23. That's the answer. This is one of the most interesting questions in this section that I found. Let's read it. This does require a lot of visualization, thinking about the series, thinking about how is the pattern moving, and then working it out. Let's read it. A table is in the shape of a trapezium. I can see the table is a trapezium and can seat 5 people. So one table can seat 1, 2, 3, 4, 5. 5 people. When 2 tables are put together, 8 people can be seated. Now, usually it should be 10. 5 times 2 is 10, but because of this edge here, there are 2 seats that were cut off. So instead of 10, now there are only 8 people that can be seated on 2 tables if they're joined together. The question is, what is the smallest number of trapezium tables required to seat 2,023 people if they are all placed in one row? So that means we just keep adding the tables next to each other. How many tables would be needed to seat 2,023 people? Now, first of all, you have to spend some time looking at the series here, what is happening, to understand how to proceed on with this question. Now, after a lot of consideration, we found that these two people here, they do not change. It does not matter whether it's 1 table, 2 table, 100 tables, or 1,000 tables. There will be always these two people who are sitting on these either sides. So in our question 2023, again, there would be two people, those who will be sitting on these two sides. So we can take those two people away. So we are worried about 2021 people. Those are the people we have to get seated. So these two people will be seated anyways. Now, actually, if you come to this step, you don't have to actually form any sequences. Now it's easy. Apart from these two people, if we leave these two people, every table that we join can seat 3 people. 1 here, 2 here. Okay, 3 people here. Although it might seem very different and you might get confused, but actually look at that. The next table that you join, although the pattern is different, you're 2 here and then 1 here, but in total there are 3 people again on this table. And if we keep joining, we have, even if we had another table, there would be 1 more here and 2 more here, but in total there would be 3 people. So every table that is joined along, there will be 3 people that will be added on. So 2021 people put into groups of 3. 3 times 6 is 18 to carry over. 3 times 7 is 21. 1 exchange. 1 carry over. 3 times 3 is 9, and remainder 2. So we have 673 tables, and there are still remaining 2 people. Now remember, this is a critical step, so our answer is not 673 because there are 2 remaining people and they need seating as well. So we will have to join another table, and but of course, because we could add 3 more people, but there are only 2 people remaining, so just be aware that there would be 1 seat empty, but we still need that extra table. So 673 full tables plus another table to account for these 2 people. So we would need 674 trapezium tables to seat 2023 people. All right, question number 30, moving on to the last question of AMC 2023. And this question is worth 10 marks. And this is supposed to be the hardest question on the paper. But actually, I felt this year the question was not actually so tricky as it had been in the past years. And it's very interesting as well. Let's have a read. Yifan has a construction set consisting of red, blue, and yellow rods. All rods of the same color are the same length, but differently colored rods are different length. So all red rods are the same length, but they all might differ in length from blue or yellow rods. Similarly, all yellow rods will be the same length, but not the same as blue or red rods. All right, she wants to make quadrilaterals using these rods. Remember, they are using the word quadrilaterals, so it can be all same, all different. It can be trapezium, parallelogram, rectangle, square, anything. It just requires 4 sides. So 4 of these rods will join together to make a quadrilateral. It does not depend on the length of them. Now, there are some clues that they have given. When she uses 2 red, 1 yellow, and when she uses 2 red, 1 blue, and 1 yellow rod, the perimeter of the quadrilateral is 36 centimeter. Let me write it down. So I will 2 red. I am using the letter R to represent the length of red rod. So 2R, 1 blue, and 1 yellow rod together, they join to make 36 centimeters. The perimeter becomes 36. Let's go on to the next clue. I'm just making number sentences right now. When she uses 2 blue, 1 red, and 1 yellow, the perimeter is 35 centimeter. Let me go back. So 2 blue, 1 red, and 1 yellow. When we use all these, the perimeter is 35. I'm not using units right now. You're just making number sentences. When she uses 2 yellow, 1 blue, and 1 red rod, the perimeter is 33. All right, let's write that down too. So 2 yellow, 1 blue, and 1 red. and the perimeter becomes 33. So these are three equations in three variables that we need to work out. Now, it might seem actually very difficult, but if you think about it, if I just add all of them together, remember thinking about all those rods that make these three quadrilaterals and putting them all together, that you're adding the whole of this plus the next perimeter, then the next perimeter. So putting all of these sticks together, and let's see what do they count to. So I can see there are 2R plus 1R plus 1R. So let me use the red color here. So that will become 4 red rods. 2R from here, one from here, one from here. Similarly, let me say blue. So 1 blue, and 2 blues. So it will be 4 blues. And yellow might not be visible, but I still would take yellow. So there are 1 yellow here, 1 yellow here, and 2 yellows here. So if we add all the rods together, that will become 4 yellow, and these together, 36 plus 35 plus 33 is 104. Calculators are allowed in middle primary, so you can use a calculator, or just 30 is 90, and you can easily do 5 plus 6 plus 3, and that is 14. So the total is 104. Now from here we can see we can divide the whole left hand side by 4 and the right hand side by 4. Let me move it up. So this becomes red plus blue plus yellow is, this 2 is 4, 6, 26. All right, this is the equation that we have been looking for, and this is our savior equation. All right, let's have a look how this equation can help us get the answer. Now, if you compare this equation, so if we had 1 red, 1 blue, and 1 yellow, this will amount to 26. But look at equation number 1. It had 1 yellow, 1 blue, but instead of 1 red, it has 2 reds. So if we had 1 red, it's 26. Just adding another red here adds 10 more to the equation. Here is 26, here becomes 36. So just adding 1 more red, it makes it 36. So of course we can work it out. The red should be 10 centimeters, that means. Here is 26, adding 1 more red makes 2R, and the equation changes to 36. Similarly, comparing this equation to the next equation, we have red, blue, and yellow is 26. In the second equation, we just add a blue more, and the answer changes from 26 to 35. That means our blue must be 9 to change it from 26 to 35. Similarly, if we compare again this equation to our third equation here, we just added another yellow here to this equation, and this changed from 26 to 33. We already had a red, blue, yellow. Red, blue, yellow. We added another yellow, and it changed to 33. That means yellow must be 7. So we found, actually, you can see we found the measurement for all our different colored rods. So red was 10 centimeter, blue was 9 centimeter, and yellow is 7 centimeters. Now let's read the question. What number do you get when you multiply the lengths of one rod, 1 red rod, 1 blue rod, and 1 yellow rod? So this is easy. You just have to multiply 10, that's red, length of blue, and length of yellow. So 9 times 6 is 63, and then multiplied by 10 is 630. So this is our answer, 630. This is an excellent question. 10 marks question. I hope you got it right in 2023. Do check your answers, and I hope you all score really, really well. All the